Okay. All right, you guys ready to see some science demos? Yeah. Where's Steven?
Where is he?
Him! Stephen the Magnificent has arrived.
What are you going to do?
Well, we're doing magic. I have a magic hat. I got a box of magic stuff. We're doing magic. It ain't my other hat. I have all kinds of magic things. I'm going to do magic. That's what we're doing, right? Magic. Right?
Maybe. Yeah. Sure.
All right, ready? Which one's bigger? Which one's bigger? Which one's bigger? See? I know magic.
Magic?
Yeah, I'm good.
Is that magic?
Yes. Magic. What do you mean they're the same size? No, they're not. All right, well, I'll be a wizard. Not just a stick, it's a wand. Have you not seen Harry Potter? So what are you guys gonna do?
Hold on. If that's magic, I'm gonna do some magic. You ready? All right. Very simple. I have some water in a cup. You guys watch. Ready? Here goes my water. You guys saw that? Everything good? All right. I'm gonna dump it on Steven. You think that's a good idea? I do too. Come here, Steven.
No, no.
Okay, hold on. Since that looked like magic, right? Hold on, that looked like magic. All right. How about I show you what I did? Inside one of the cups, I had what's inside diapers.
You mean like, wait a minute, what do you mean inside diapers?
Stuff inside diapers. So what I did was, I dumped one cup into another cup, and you saw the water, right? This into here. But then when I dumped this into here, that soaked up the water really fast. So when I dumped it over Steven's head, nothing. Because it soaked up all the water.
You're a wizard,
So
Billy.
that's science, not magic. Huh.
Huh. What do you got?
What do I have?
That looks fancy.
This is some good magic.
I have a balloon. Okay. I'm gonna try to pop the balloon.
Sir, can we turn it around so it's not going towards the kids? There's just a large group of eyeballs over there. You know, I get nervous. All right, so what are you doing? What are you doing?
So I'm gonna try to pop this balloon with the laser.
Close your eyes.
Okay. Yeah. 3, 2.
Wait for it, you'll see.
Boom! Oh, I didn't go.
I jumped. Wait. Turn it around. Yeah, it's an angle thing. There. Now can you see it? That's
How long is it gonna take?
3 days.
It's not popping, Sarah.
Maybe I need to try a different one. Steven, is there a different balloon we could try?
How about this one?
Yeah, let's try a different
that
balloon.
one?
Maybe there's something wrong with this balloon.
Were you using this?
No, I wasn't going to use
Here,
that.
I'll try this. Let's go. Let's see. Ready? Maybe this helps. Ready?
Okay.
Yeah. All right, Sarah. What happened there?
What color was the first one? When you go outside in the summertime, what color would you wear to feel nice and cool? What color would you wear to feel nice and cool outside on a hot day? I'd probably wear a light color, right? On a hot day. But what color would I wear and it probably made me feel warm? Hot day, wear black. And that's what's happening there. That black balloon absorbed more energy quicker and popped.
So darker things absorb energy, and it's science again. Science is kind of beating magic. Did I show you guys this one? Oh, we seen that one?
Yeah.
Oh. Bill, you have something?
Yeah.
Yeah, you know, I didn't know that.
Okay. Here's something that's going to make, I like, you know, in magic, you make things disappear, right? Yeah. How many times you seen them put someone inside a box and then they disappear?
Give me $1.
To make you disappear?
I'll make it disappear.
I'm going to make a balloon disappear. Okay? Very, very easy. Not dry ice. All right.
Oh, he wouldn't lie.
Okay, here we go. We're going to make it disappear.
It's not dry ice. Keep thinking. Put your thinking caps on. Shh. Put your thinking caps on.
So wait a minute. It disappeared. That big, huge balloon just went away. You ready?
Not acid. Not acid, no. We wouldn't have acid up here.
And now it's back. Made it disappear, and then it came back. Did it disappear? Not really, right? It's still there. So here's what I did. You were right. What's in here is really cold. It's called liquid nitrogen. Okay. So what I did was by putting this down in here, what is it doing to the air inside the balloon? Even your teacher was like, yeah, I made it got closer, right? So it's getting it all the air in there real close. So imagine if your arms out real wide, and then you guys bring them in real close. So guess what? All the air inside this got real close. And then when I brought it back out, and I put it out there, what's it doing? It's expanding back. Kind of looks like magic, but it's science.
Nice. You got one ready?
Yeah.
Yes. I like that. Someone mentioned that's why he's wearing gloves. This is cold enough we would get frostbite. It would really hurt him. That's why it has to be safety. He has safety glasses on. He has gloves on. He's being very careful.
All right.
What do you have?
I want to make a cloud in a bottle. Oh, yeah, I think we can.
There wasn't any clouds outside.
Yeah, no clouds today, and I want to make one. I want to see a cloud right now. So I got nothing in my bottle. Is there anything in this bottle?
Yes.
There is something in it.
Air.
Air is in this bottle. And what do I need to make a cloud? Air? You need air to make a cloud? Air and water? So there's some water in here. Someone rinsed it out. It's rinsed out. So there's some water. There's some air. Okay. Does this right back? Oh.
How about I hold the bottle?
Okay, Bill's gonna hold it for me. Okay. All right. So right now we can squeeze it. I'm gonna put some air in it. What do you think? How does it feel now? Oh, it's pretty full. So,
Take the top off?
yeah, let's take the top off. Oh, you see a cloud? Kind of. Huh, well, I want a better cloud than that. Water?
Yeah, here's water.
Okay.
I felt so you could pour it easier.
Oh, okay, okay.
It's just water out of the faucet.
Okay, so I'm going to pour some water in this then. Maybe we just need a lot of water. Okay. All right, I'm gonna add air to this. We'll look really close. Try to see when that cloud forms.
Is there a cloud?
Look real close. Do you see a cloud now?
Make it go away.
Maybe I want the cloud to go away.
Make it go away.
Watch it. Is it still there? No?
Do you want it to come back?
All right, so let's talk about what happened there. Hold up. Let's talk about the science of what happens. Clouds don't just happen on their own. There has to be things in the air, right? And what did you guys say it needed? You need water, right?
Yeah.
And so you have to have water for clouds. Clouds are made of droplets of water or ice if they're really tall. Have you ever heard the weather guy say that there's a high pressure front coming through, or weather gal, whichever it is? She doesn't say as high deep a voice as I did, but there's a high pressure front coming through. So the high pressure front, the more pressure, what kind of day do we have?
Mm-hmm. A really high pressure, it's going to be like a day like today where there's not many clouds. We look up in the sky and there's not many clouds there because I'm going to say that wrong. There's a lot of pressure.
The water's still there, right?
The water's still there.
The water's still there, but high pressure, if it's really high pressure, we hear them say that, what's happening is that high pressure, it supports more water vapor.
Yeah.
And so, we're talking about the water cycle now, where water turns into gas, thank you, right? And so we have water vapor. And the water vapor, high pressure supports, but low pressure, it doesn't support as much water vapor.
So when we have a lower pressure day, we got more clouds because it doesn't support as much water there mixed up with all the air. So we get the cloud to form.
All right, so the science is looking pretty cool.
Science is a lot of fun, right? Okay, so I told you guys what's in here, right? What's in here? Liquid nitrogen. Okay, so I want to see something. Okay, watch. See that one? What's going to break? So because that was so cold, that racquetball just shattered. Okay? Now, this racquetball sounded like a piece of glass, didn't it? But because it was so cold, it's so pulled together, everything got real tight, so it couldn't go anywhere when I went to bounce it, so it had to break. As opposed to the one that is not pulled, still bounces just fine. Do it again. Do it again.
We got more.
I'll put this ball in here and later we'll do it again.
Take it to her. Got another?
Yeah.
You got one ready? Any time?
Yeah, I do.
Okay.
Screen is big. Would you mind passing him one of the mics? It will not pick up anything he's saying.
Where is? Okay. All right.
Okay. All right. I have this water, and we're going to make some observations, all right? So what color is this? Clear. Okay. And what color is this? Orange. And sometimes we can mix things together and they're going to change colors. And when we get a really drastic color change, I'm not talking like this gets a lighter orange or a lighter yellow. I don't mean that. I mean when the color really changes, that's when we know that a chemical reaction takes place. Okay? So I'm going to see if I can change this water into blood. You want to change water into blood? Okay. Water into blood. Ready? So we're going to do 3, 2, 1. Ready? Is it actually blood? It's not actually blood. I was teasing you. It's not really blood. All right. But what color is it now? It's pretty bright red, almost kind of a dark color. It kind of looks black. It's so dark, it almost kind of looks black. We know that a chemical reaction took place because there was that really drastic color change.
That's not really blood, is it?
It's not really black. No, it's not.
Oh, it's not going to feel well.
Okay, it's not Pringles. You know what, though? They were good. I'm not going to lie. They were really good. We ate. I thought you didn't like Pringles.
Did you eat them for lunch?
Okay.
Well, you guys had other chips.
I'm going to put a little liquid nitrogen down in this Pringles can, and I'm going to have Steven step out in front.
Wait, why?
Okay. Yeah, you can. Oh, wait a minute.
You lost the lid.
Why is this? Why is the air pushing it up though? You know what? Here, they said I'm pushing on it. Go ahead, you can put it on here. So, what we know is that the liquid nitrogen there is really cold. So when I put it in here, right away the liquid nitrogen is heating up. And when it heats up, what happens when things heat up? They do what? Well, they boil, so they expand. So, we're going to do a second part to this. So does anybody know what this is? It's a tea kettle. And when you put a tea kettle on the stove and you put water in it, you have it get to the point where it starts to get hot. What happens when the water gets hot? It boils, and then what happens with the tea kettle? It whistles. So watch. Is that you doing it? Okay. I thought it was them.
I'm not a professional whistler. All right, let's listen carefully. No whistling. I don't know.
So I'm putting a really cold liquid. I don't want the ball. Okay, you ready?
Gently.
So what we have is we just have that liquid in there getting hot, and it's actually boiling. But it's boiling, it's cold going just to warm, where water normally would be cool going to really hot. But this is going from really cold just to warm.
But it's still increasing
It's still increasing the temperature.
So you have to be an increase in temperature, and then the gas escapes.
And then the
that
gas
makes the
escapes.
whistle.
Yep.
I like that. All right, so did I show you guys this one yet? Wait. I got a magic wand. Did I show you the one magic wand yet? Show you that? Here, hold this one.
Whoa!
Phil,
I
you
broke it.
Can I show you that one?
Yeah.
How about this one? Have you seen this one? All right, how about Bill? Sarah?
Yeah.
I'm gonna sit down.
Ready?
You want to hold your watch? Got a watch for sale. Who wants it?
Ready? Hands on.
Probably.
Go.
All right. I want you to watch my hair. Oh my.
Oh. I got you.
I'm having a bad hair day.
That was some good spark on your leg. You all right? Okay. Is that good enough?
Yeah. You are having a bad hair day, Sarah.
So I want everybody to watch this because I think this is almost just as neat as her hair going out. So Sarah's going to step off, and when she steps off, what do you think is going to happen? Okay, so you think all the hair is going to fall. Go ahead and step that way. Don't step towards me.
George stepped over the hill, not me.
Okay, it kind of fell, but look at all the hair that's still standing. Now, put your hand on the table. Boom. If you didn't see the last, but there was some hair still standing, and when she touched the table, all the hair fell. That's what we call being grounded. Okay? Not grounded like you got in trouble grounded. I didn't even think about that. Grounded in the fact that all the electricity that was in Sarah's hair eventually went down through and went back into the earth.
You need to discharge that?
Yes. Good.
All right.
All right.
Make sure it's safe.
Good.
All right. Well, that was a hair-raising experience.
Let's do the Vortex Cannon. Yeah. No, it's warmed up. I just got.
Next, let's see. I need a very quiet volunteer. Oh, we'll take Tom behind the camera. Stay there, don't move. We're going to toss something to you.
Get him. Hold on.
All right, have a seat.
All day long.
What is going on, Bill?
Where did they go? Oh, you're still here. Okay, couldn't see you.
Yeah, it got a little cloudy in here.
Okay.
Wait a minute, what happened here? What will happen?
So this is called a Vortex Cannon, and what happens is I filled it with smoke, and on one end is just some rubber so that we can push the air, and as it hits that hole, it pushes out the smoke, but it pushes it out in a ring, and if you watched it, it actually is curling around itself as it continues to go out. So that's science,
What are you
not
doing?
magic.
That it was magical.
That was. Did you guys like that one though? Yeah, that's pretty cool.
Okay,
All right, Sarah.
I want to try magic again. I want to try to make a crystal ball. All right.
I like crystal balls.
Yeah.
Who doesn't like a crystal ball? You all don't like crystal balls?
Oh,
Huh? Got to watch the question you're getting
Okay.
asked.
All right, ready?
It takes a couple. It does that things. Okay, watch.
Okay. Can you touch it? All right, I'm gonna look into my crystal ball and see if I can tell the future. Ready? Oh. Let's try it again. I'll try it again.
Hand me the dry ice.
Okay. All right. Almost there, right? Really big. Okay. I'm gonna let it go really big this time.
Do it! Do it! Oh! So
Not very
close.
good. Not very good.
That was close.
what's happening here?
So
That looks magical.
it does look magical. It does look magical. Have you heard of dry ice? I put dry ice in some water, and then this strip of cloth has some soap on it. And we rub the soap all along the top and make a great big bubble. And it's kind of like when you go outside and blow bubbles. All right. Oh,
Now it has enough soap in there. It
not as
wants to
much.
go.
Yeah. Yeah.
So in sticking with what Sarah just did, I've got kind of a similar thing, but this one was where they drop. So I just have some soap solution in here. And these, perfect. They drop. So what do we know about carbon dioxide? Is it heavier or lighter than air? Here's the thing, if it's heavier, it would float. If it was lighter, it would float up. If it's heavier, it's going to drop. So what do we know about carbon dioxide? It's heavier. Look at it drop right down to the ground.
I can't. What? What?
Not today.
I want to do a couple more demos first.
Yeah.
We might have that on the way out or something, so we can throw a couple.
I can reset that.
All right.
Hey, you have another one, or do I need to do one?
You want to do one? You do one. Yeah.
It's making sure you're all paying attention. Gotta keep.
How about this one? Wait a minute. Wait a minute. Nope. All right, this one.
Wait. That's not from that. Okay, watch. He's doing magic.
Hold it. I'm stuck in there. Wait for it. Hold this.
Okay.
I'm taking the wand over there. Hold this.
Okay.
All right. Now it's in.
Okay.
All right, give me the green one.
Okay. Green one.
Oh, that's part of a ball.
That's part of the ball. How we doing?
Good, 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 good. Wait for it. Wait for it. There's not a blue one. What there is.
Oh!
I'm gonna get some.
You got one? You ready? Go ahead. Oh, yes.
All right, what's going on here, Sarah?
Well, a little bit of a problem. I need to brush my teeth after eating that pizza. I ate that pizza and now I need to brush my teeth. What do you guys use to brush your teeth? Toothpaste? Well, the thing is I need a lot of toothpaste. Well, that's a good thing because my pet elephant at home, its breath's pretty stinky too. So if we could both brush our teeth at the same time, that would be great.
I wouldn't brush my teeth with that.
You wouldn't?
You do have an elephant at home.
I do have an elephant.
I know.
I know, I do.
You got to clap.
What makes it that much? Why does it get to be that much? What do you think? We do use some special ingredients. I agree. Yep. What's that? I know, and elephants have lots of teeth and they need to brush it. But
That smells
so
good.
we talked earlier about we saw a color change, right? We made fake blood, like for Halloween, we made fake blood. We saw a color change. Something else that shows that a chemical reaction has taken place is it makes a gas. So if something makes a gas, then we know a chemical reaction took place. This makes so much because it forms a lot of these little air bubbles that get trapped. I put one of the special ingredients was soap. And we know, we've been watching these bubbles with the soap. When we fill those bubbles with lots of gas that's made in the chemical reaction, it makes a lot of volume. It makes it look really big. All right.
That was
Good
awesome.
job with the chemistry.
Yeah.
Way to step up. Now what's next?
I got to get my gloves off.
Oh.
Okay. I got a little thirsty. I'm ready for some Sprite. Anybody else?
One thing I've learned: never cross Bill.
This is really Sprite. I'm not. There's no trick here. Remember, he's the one trying to trick you.
I did magic.
We're showing science,
I did magic.
which is a trick.
Magic. I heard somebody say all magic is science. Well, magic is just something that's mysterious, something we don't know, right? And a lot of magic, usually about all magic falls into two things. One, it's a trick or a sleight of hand. Or two, it's science. What are you doing?
I am going to add raisins.
No.
It will.
Yes, your raisins are dancing. Why are your raisins dancing, Bill?
So some people will think that this is magic because they see all of a sudden the raisins at the bottom go to the top, and then eventually some at the top drop down to the bottom. This is something you can do at home. You can do this in an own glass at home with Sprite and raisins, and this will go for quite a while. So what we have is we have the carbon dioxide that's on the bottom or in the pop. That carbon dioxide gas is getting around, and if you're up here close, you can see all the bubbles around the raisins, and then it starts to get enough bubbles around the raisin that the raisin gets lifted to the top. And then when the bubbles get to the top and that bubbles release out above, then the raisin drops back down. And this will just sit here and do this as long as there's that carbon dioxide in there. By the way, that carbon dioxide is the same stuff that Sarah was using a minute ago with the bubble that's still there.
Wait. It's dry ice?
It's dry ice. So what they do is they take the carbon dioxide gas and get it really condensed really fast under pressure, and it turns it into an ice, to a solid.
They call it dry ice because there's no water. It's just carbon dioxide that we breathe out. We breathe it out as a gas, but when they freeze it, it makes it solid. They call it dry ice.
Cool.
Dancing raisins. The requests of the people I had my earphone in. The people online,
Yes.
they want to see you dance with the raisins. Go ahead.
I'm not sure how a raisin dances.
Can you guys do me a favor? Give a little clap. Let's keep going. Hey, hey, Steve, dance with raisins. Steve, dance with raisins.
Do you want to take that one last? Do you want to get the balloons?
Oh, I can do that now? Yeah.
Yeah. You want to do something? You get balloons.
All right. So, Bill, you have something, or do you need me to?
I got something, see. I'll do it back here, right? Well, not do it. Okay, so I've got two balloons here, okay? What do you normally put into balloons? Okay, so air that you blow into, or helium. So if I put helium into it, what happens? Okay, so it goes up, right? So that's helium. This one doesn't have air that I blew in, but definitely has a gas. Mm-hmm. Steve's got one right here that has air in it. Go ahead and drop that one. You see how that kind of floated down? Okay, now watch this one.
Bill, let's drop them at the same time.
So
let's drop them at the same time.
Let's do all three.
Okay.
Ready? 1, 2, 3. So this has a different gas in it, and this gas is very heavy. So maybe you don't trust me because you just met me today. I hope they trust you. Come up here. Yeah, come here. Come here. Well, they don't know me. Okay, so I just want your teacher, I want you to feel that one. Okay, feel. Okay. Now feel the one Sarah has. That's the regular air. Okay, go ahead and hand that back to her. Now feel that one. What's that feel like? It feels squishy, feels heavy. Shake it around a little bit. Is there anything else inside there? No, it's just a different gas. It's a gas that's more dense. The molecules inside there are closer together, which then, go ahead and you can drop it this time. And when it drops like a lead balloon. Versus this one, when you release it, goes right on up. Cool? So, I can't do this today, but maybe you guys have seen this. When people take and it's not a good thing to do. I don't go home and do this, but if you inhale helium, what happens to people's voices? It goes really high, right? It goes real high. That other balloon, if you inhale that gas, it will make your voice go really deep. So this is really, makes it go really high. That one, I can't try it.
Oh, no, it's not a safe thing to do. That's not a safe thing to
But
do.
it'll make it go really, really. You have to have really good, clean gas of this to do it, and we don't do it. Yeah.
We got a water balloon for you. Are you going to put that in your liquid nitrogen?
Oh, I guess I could. You dance with the racing though. Oh, I do have one more on here already. Okay, I have another one that we're going to do. I think I got to do it on this table. I am going to do the banana. How did you know that? It's right there. You saw me put it in. All right, so I've got a banana that hasn't been put in liquid nitrogen and one that has. So how do you tell the difference? Well, I'm going to take this one and I'm going to go. You can eat that one. So frozen banana is very fast. Is that a good banana?
Whoa, whoa, whoa.
This one's cold.
Mm-mm.
That one's really cold. You got one more?
Well, yeah, last one.
Go ahead. Oh, you're gonna do that. Oh, the. Let's just have her do the last one. Yeah, let's go ahead.
All right.
No, teacher helpers. Do we need that? Oh, you got the can.
Forgot to. Gonna light a splint.
Huh? Say it again.
I was gonna light a splint.
Oh, yeah. Want some raisins?
All right. As you can help out, they're passing out something. Sarah?
Yeah.
What? I'll let you walk them through what to do.
All right.
Thank you. How do you do that?
Huh? How you do what? We're going to prosper?
No, you dropped your pinky down. You can't do that. Hey, watch him. Put your,
Stop. Thank you. Took a little bit long. Come on.
I can't do that.
All right, Sarah.
Okay. You have a special set of glasses. These glasses are going to help us see things that are really cool. We're going to make a rainbow right here in the classroom. All right?
Wait a minute. You're going to make a
We're going
rainbow
to make a rainbow
in the classroom.
right here in the classroom. But to see it, we've got to have the glasses on our face. Now,
You want the lights off?
yeah. So, to see this the right way,
Hold up. Kill 'em.
everybody watch up here.
There, now you're ready.
We ready? We're going to turn off the lights.
All right, hold on. Bill, shut the shut.
Those look good on you guys.
So we can see this a little bit.
Don't wear those while you're driving.
You just have to look down towards the front, and we're going to watch for the rainbow.
There we go.
Not only does he sing, he dances. Ready?
I was trying. All right. That was really cool, Sarah.
That's pretty cool.
But tell me, can you?
Is that magic?
I think so.
Is that are rainbows magic?
Are rainbows?
You can still see it, right? We can see it better when the lights are off. We can see it better when the lights are off. We can kind of focus on those. But when we have white light, which is like light from the light bulbs or light from a flame, we can diffract it. We can put it through a special lens like what you have over covering your eyes, and it's going to separate out all the different colors that are in white because it takes all the colors to make white light. So that's what we have. We have the prism glasses, and they separate them out so we can see all the colors that are there.
We're not going to do that again. However, it's like 1 o'clock. However, you can slide that back in the package, slip that in your pocket, and take that home. Oh, yeah. Thank you. That's like a really, really good, important thing. All right, hold up. Listen up. I need every single person's attention. Something very important that we had not told you yet. What? Oh, yeah. Something very important we have not told you yet. Never, ever, ever look at the sun with these glasses on. Because it'll blind you. That's why. All right. Now, and this brings up something really, really important that's going to happen here not too long. Because Indiana, in like next year, we're in a partial eclipse. The year after that will be a full eclipse, a little south of where we are. Never look into the sun for any reason with your eyes because it could damage your eyes. And when it's time for us, when the eclipse comes and we want to look at the eclipse, we have to have very special glasses in order to be able to look into the sun because they filter out almost all the sunlight, and so it doesn't hurt our eyes. But I don't know. There's a whole group of universities and organizations around Indiana that have been meeting, and we're actually working on funding to get every student in Indiana glasses in the schools. But that's a whole other thing. That's what they're working on. But so never, ever, 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 not even if you have sunglasses on. Sunglasses don't protect you from looking into the sun. It can still really harm your eyes. There's a lot of energy there, a lot of intensity there. And these, this diffracts the light. That's really cool. It's really neat to be able to see a flashlight or light coming in a window. That's all right to look at, but never, never look into the sun directly with these, all right? Yes, it's way too bright. All right, you guys have any more?
I think we are done.
You're done?
I think he's going to finish with one last one. It's frozen. It won't do anything now.
Sarah?
Yeah.
There.
Okay.
Hold these.
Okay.
All right, give me a ring. Ready?
Ready.
Sure.
Mhm.
All right. Oh man, there's feathers falling out of it. All right. Let's stuff that in there.
Okay.
Give me another one.
All right.
Oh wait, am I supposed to do ring or collar next? I don't remember. Do you remember? I don't remember. Maybe a collar. Got that? Got that? Okay. Wait, did I put the white one in already?
Mhm.
Oh. How many did I put in?
2.
2. Yeah, give me another one. 3.
Okay.
All right, give me one of these. Is it in there? Okay. So you can see what's in there. Is it in there? Promise? All right.
They're all watching.
All right, they're all in there, right? Can we see through it?
No.
All right, stuffed in
No,
there. Ready? That's magic.
Yay!
Show me the white one again. All right. I'm showing you the white ones again. You ready? I gotta pull this one up. All right. Yeah, let me stick it back in here and see if we can't make it white again. You ready? Look at it.
What?